Hey guys, how are you? Welcome to part 3 or chapter 3 of my C++ for Windows tutorial. We're getting back into the programming part of it, and we're going to start looking at a bunch of the different data types that are available to us so we can start manipulating all kinds of different things. So, as a quick note, this is going to be the last time I'm actually going to create a new project. From here on in, I'm just going to have a new project created, so I'm not going to be walking you through the steps anymore. So, as always, create a new project, select empty project here, hit next, and name it. We're going to name this one data types. I like using no spaces, and create. So there's a few things I want to be covering in this video. I have them all written down right here. Oh, where'd that go? Alright, so we're going to have a look at what comments are. Of course, we're going to look at our different data types, and we're briefly going to cover what a constant is. So, as always, source files, add new item, cpp file, source.cpp is fine for me. And let's write out our skeleton for the code. Okay. So, a comment is essentially just a way to help document your code or take out a part of code temporarily. So let's say we had our old Hello World program again. Well, what we can do here, let's say we didn't want it to print Hello World anymore. We can just put 2 slashes in front of it, and you'll see the entire line turned green here in Visual Studio, at least with my color scheme. If you're using a different editor or a different color scheme, then yeah, it will be a different color, but yeah, the important part is that now the compiler will completely forget that this line even exists. It won't even process it, it won't parse it or anything. So, sure enough, if I hit run, what happens? Nothing happens. Exited with code 0 because we are returning 0. But if I take out these 2 slashes here, what happens? You'll see we get hello world, new line, as expected. Now, let's say we had 2 lines of text. Okay, no syntax errors, nothing wrong here. Well, I mean, I could always just put slashes in front of both lines, right? But there's a shorthand way if you're doing lots and lots of different lines of code, and that's essentially slash, asterisk, and you see the entire area from this point on turns green. We don't want it, or we don't want the entire thing to turn green, of course, because we still need to return something. We need to finish off that block here with the brace. So instead, at the end of it, when we're done commenting, we put asterisk slash. Those are forward slashes, by the way, not backslashes. And you'll see only these lines turn green. This one still going to get processed. So if I hit this, run it, nothing happens, returns with code 0. So that's enough about comments. We're just going to be using them a little bit later on just to help document things, keep things cleaned up. So we are looking at different data types today. And the first thing I have listed right here is int, or short for integer. And you'll see we're actually already using it over here as a return value. This is what we call a return value in programming. And as you can see, we are returning 0, and that's our exit code. And that's just a standard that's used in a lot of programming. Whatever the main function returns will be the exit code. Usually it's going to be int. I've seen things like void and a bunch of different others. It was really weird. I don't like it. Int is usually the safe way to go. And yeah, so an integer data type, I'm just going to use comments for this. An integer holds 2 bytes by default. And I say by default because we can actually change that. There are all kinds of different optimizations you can do and different notations. But if you're just typing an int right here, that is just 2 bytes of data. Or in other words, hang on, I'm just going to open up this comment a bit more. In other words, that would be 256 by 256 minus 1. Wait, am I doing that right? No, I'm not doing that right. I had it right the first time. Sorry, my math isn't the best. Anyway. But, yeah, as we said, you can hold more with it. You can hold up in powers of 2. So this holds 2 bytes. We can hold a single byte. Or no, we can't hold a single byte. But anyway, yeah. We can hold 4 bytes, 8 bytes. And each of those have their own different bit values, right? Next thing we have on our list is char. And char is short for character. And one character, as we've seen, is any single one of these letters here. It could be one of the spaces here, that new line. That's one character. This is one character. This is one character. And as we touched on briefly in the last chapter, these values all correspond to the ASCII chart. And that's essentially what it's doing. It's converting it to an ASCII value, which it can then output as a regular character. So, one character, if it corresponds to the ASCII value, then it must be 1 byte long. And this is completely non-negotiable. One character will always be 1 byte. Next up on the list, we have floats. And float is another number value. It's like an integer, it holds a number, except it is 4 bytes long usually, by default at least, so it's 32-bit, and it holds decimals. And that's why it's called float, it's short for floating point value. Because the decimal point is essentially approximated, because computers aren't really that good at splitting up numbers in weird ways like division would do, because yeah, they only use zeros and ones. Those are very distinct, like hard values to try and represent every other number with. But that's what we use, and it sort of tries to approximate the floating point, the actual decimal part of it. So, holds 4 bytes. And the last thing we had on the list here was the Boolean value. And if you're not familiar with Boolean math, that's alright. But I do suggest you do take a quick look at it. It's mostly just logic-based. Boolean values are only a single bit long, actually. But, well, they're technically a byte, but we are only looking at if it's greater than 0. And what the Boolean dude, or Boole, the mathematician, he coined up is the idea of true and false. And you've probably heard that a lot with computers as well, because 1 is equal to true, 0 is equal to false. Except that's not always the case. In computer science, a Boolean value is 0 if it's false, and it is 1 to 255 if it's true. Anything greater than 0 will always be considered true, and that's why it's going to be at least a byte long and not just a single bit. Also because the computer's split up into bytes, which are then split up by bits, so naturally it only makes sense to use a single byte for that. Oh, I have a typo here. Now finally, before we run out of time, we have constants. And constants, well, they're like, consider it a data type that you can't actually change. Like, for instance, if we're going to be dealing with variables of different sorts, then a variable is able to be changed. That's what the name implies. So we'll talk a bit more about variables later on. I just want to get constants out of the way for the sake of understanding our code a little bit more from Hello World. If we have int b equals 32 semicolon, that is a variable there. But we can also declare a constant as const a equals 1. Oh, forgot. Const int a equals 1. Save that, no syntax errors. Now, we could always change b to something else, and it should be able to work. But if we try to change a, you'll see I'm already getting an error on this. It's constant, so the expression must be a modifiable value. And if I try to run this, it won't even work as a result. So constants cannot be changed, and we were actually using a constant up until this point. So I'm not sure if you caught it. I think I briefly mentioned it, but this thing right here, this is a constant. However, it all looks like complete BS to you if you've never actually done a lot of programming. But this end-L is part of the IOStream library. It's defined as a constant. Something like const char end-L equals \n. Something like that. Is this even going to work for me? I think so. Yeah, look at that. It works. But the point is, yeah, it's defined in this library, and if I were to take this library out, wow, first of all, this is gone, and second of all, this end-L is also gone. So that's the importance of using IOStream at the beginning, right over here. Oh, I forgot all this. And I can't type. That works. So if I were to run this, that works fine. And you'll see if I take off this end-L over here, and I run, now I don't have that new line there. I get the one that Microsoft by default gives me to give the exit code and all that, but that's mainly from the debugger. Alright, so I think that concludes it for this video. I hope you enjoyed. We're going to start talking a bit more about variables and constants and how to use them later on next video. So yeah, look forward to it. Peace.